Hello friends, today we discuss about in our tech channel about Mosfet continual lecture. In our first part we will discuss about Mosfet basic introduction, P-type, N-type Mosfet. Now we discuss Mosfet region of operation. The most general scenario, the operation of this device happens mainly in three regions, and those are follows: its cutoff region, saturation region, linear ohmic region. In this region where the device will be in the off condition and there's zero amount of current flow through it, here the device function as a basic switch and is so employed as when they are necessary to operate as electrical switches. Basic switch, and it is employed as when they are necessary to operate saturation. In this region, the device will have their drain to source current value at constant without constraining the enhancement in the voltage across the drain to source. This happens only once when the voltage across the drain to source terminal increase more than the pitch of voltage value. In this scenario, the device functions as a closed switch where a saturated level of current across the drain to source terminal flow. Due to this, the saturation region is selected when the device are supposed to perform switching. Linear in the region where the current across the drain to source terminal enhances with the increment of the voltage across the drain to source path. When the MOSFET device function in this linear region, they perform amplification functionality. Let's now consider the switching characteristic of MOSFET. The semiconductor to such a MOSFET or bipolar junction transistor is basically functioned as switch in two scenarios. One is on state and the other is off state. The considered functionality. Let us have a look at the ideal and practical characteristics of MOSFET device. Ideal switch characteristics. When a MOSFET is supposed to function as an ideal switch, it should hold the below properties, and those are: in on condition, there has to be the current limitation that is carries. In the off condition, blocking voltage level should not hold any kind of limitations. When the device function is on state, the voltage drop value should be null. The resistance of state should be infinite. There should be no restrictions on the speed of operation. As the world is not just stuck to ideal application, the functioning of MOSFET is even applicable for practical purposes. In practical scenarios, the device should hold the below properties. In the on condition, the power managing abilities should be limited, which means that the flow of conduction current has to be restricted. In the off state, blocking voltage level should not be limited. Turning on and off of infinite time restrict the limited speed of device and the limit the functionality efficiency. In on condition of the MOSFET device, there will be minimal resistance value where this result in the voltage drop in forwarding bias. Also, there exists finite of the state resistance that deliver reverse leakage current. When the device is performing in practical characteristics, it loses power on and off condition. This happens even in the transition state too. In the blow circuit arrangement, and enhanced mode and N-channel MOSFET are being used to switch a sample lamp with the condition on and off. The positive voltage at the gate terminal The positive voltage at the gate terminal is applied to the base of transistor, and the lamp move into on condition. Here VGS equal to at 0 voltage level. Enhanced mode N channel Mosfet are being used to switch a simple lamp. So we again read enhance mode. What is enhance mode? So we come above. When there is no voltage across the gate terminal, then the device does not conduct. When there is a maximum voltage across the gate terminal, then the device shows enhanced conduction. So now let's come in Mosfet as a switch and the enhancement mode. So the positive voltage at the gate terminal is applied to the base of transistor and the lay move in its own condition. The positive voltage gate is applied to the base of transistor and the lamp move into on condition, and here VGS is VGS or at zero voltage level. The device turn off condition when VGS equal to 0. If the resistive load, the lamp was to replace by an inductive load. And connected to the relay of diode, which is protected to the load. In above circuit, it is very simple circuit for switching a resistive load such as lamp or LED. But when using MOSFET as a switch either with inductive load or capacitor load, then protection is required for MOSFET device. Level diode. If in the case when the MOSFET is not protected, it may lead the damage of device. For the MOSFET to operate as an analog switching device, it needs to be switched between its cutoff region where VGS and saturation region where VGS equal to V++. So MOSFET can also function as a transistor and is abbreviated as a metal oxide silicon field transistor. Here the name itself indicates that the device can be operated as a transistor. It will have P channel or N channel. The device is not connected in such a way using the 4 source gate, the drain terminal, and a resistive load of and a voltage meter is connected across the MOSFET. The device is connected in such a way using the 4 source gate and drain terminal, and a resistive load of 24 ohm is connected in series with the ammeter, and a voltage meter is connected across the MOSFET. The transistor, the current flow in the gate is a positive direction, and the source terminal is connected to ground. Whereas in bipolar junction transistor device, the current flow in across the base to emitter path, but in this device there is no current flow because there is a capacitor at the beginning of the gate. It just requires only voltage. The transistor, the current flow in the gate is a positive direction, and the source terminal is connected to the ground. In this can be happen by proceeding with the simple process and by switching. When the switch is on, there is no current flow. When the switch is on, there is no current flow across the circuit. When the resistance of 24 ohm and then we find the negligible voltage drop across the source because there is the resistance between drain and source is termed as RDS. Due to this RDS, the voltage drop appears when there is current flow in the circuit. If the RDS varies based on type of device, it can vary in between 0.001, 0.005 and 0.05 based on type of voltage. Few of the concept to learn. How to choose Mosfet as a switch. There are few conditions to be observed while selecting the Mosfet as a switch, and those are as follows. Usage of polarity, either P or N channel. A maximum rating of operating voltage and current values. Increase RDS on, which means that resistance at drain to source terminal when the channel is completely open. Enhance operational frequency, packing kind of depack many other. What is MOSFET switching? The main restriction at the time of operating MOSFET as a switch device is enhanced drain current when the device can be capable of. It means that RDS in on condition is the crucial parameter which decides the switching capability of MOSFET. It is represented at the ratio of drain source voltage to that of drain current. It has to be calculated only in the on state of transistor. In general, a booster converter needs a switching transistor for the operation of the device, so a switching transistor MOSFET are used. These devices are used to know the current value and voltage values, also considering the switch's speed and cause they are extensively employed. In the same way, MOSFET can also be used in multiple ways, and those are MOSFET as a switch for LED, remove circle outline, MOSFET as a switch for Arduino, MOSFET as a switch for AC load,